All right, good day and welcome to another physics class. In this class, we shall be talking about, again, continue our discussion about linear momentum, right? In the last class, we have explained what linear momentum is all about. We have taken some examples to practice the equation for linear momentum. So in this class, we are going to continue from there. Now, as you can see on the screen, for today's class, we'll be able to talk about collision, right? Elastic and inelastic collision. We'll talk about what will happen to the equation for elastic and inelastic collision. Then what will happen to the kinetic energy for both elastic and inelastic collision. And that will be after we understand what collision is all about. Now, finally, we'll talk about impulse and the relationship between impulse and momentum. These are all what we shall be learning today. All right, so now let's go to take now elastic collision. Now, collision is a sudden coming together of two objects, right? An accidental um, coming together of two objects. For example, if I have a ball and another ball like this in the front, are you following? Now, if I hit this ball and it moves like this, it is going to collide with this other ball. Are you following? When it collides with the ball, right, then the two of them can move, in a particular direction, or they can move in different directions, depending on the type of collision we are talking about. So collision is that relationship, that coming together of two or more different objects in an accidental or sudden manner. All right, so now there are two types of collision. There is inelastic and there is elastic collision. What do we mean by elastic collision? Now, when these two objects comes together, when they collide, right, and they move in their separate ways, then we have elastic collision, right? Meaning that the two of them are coming either from different direction or from the same direction, or one of them is not moving, but one is moving. But at the end of the day, they collide together. After the collision, let's say they move in their separate ways, then we have what we call an elastic collision. Now, as you can see on the screen, in elastic collision, the kinetic energy before collision is equal to the kinetic energy after collision. I'm sure you know what kinetic energy is. That is the energy of a body in motion, which is always 1/2 mass multiplied by v squared. That is kinetic energy formula. Now, if we find the total kinetic energy, remember that these two objects we are talking about, they both have their mass and they have their velocity when they are moving. Even when they are not moving, or when one of them is not moving, the velocity will still be zero. So it still has a velocity. Now, because we have this, we can calculate their kinetic energy. So the total kinetic energy before collision is the same as the total kinetic energy after the collision, right? That is one characteristics of elastic collision. The second one is for a perfectly elastic collision, the relative speed of approach, meaning the speed before they collide, is the same thing as the speed after they have collided. Because after they collided, they will move their separate ways. They will still have their speed. So the relative speed before collision will be the same as the relative speed after collision. So these are important points you need to note about elastic collision. Number one is that it is a type of collision such that when the two objects collide, after the collision, they will move their separate ways, right? Then the second thing is the kinetic energy before collision is the same as the kinetic energy after collision. And the last one is that the relative speed of approach is the same as the relative speed of separation. Now, let us try to understand the equation for collision. Let us try to understand the equation. As you can see here, I told you just now that these two objects that are coming together, they have their mass and their velocity. So in this case, we are taking example of two balls, right? This is moving in this direction, and this is also moving in the same direction. Now, before the collision, this has a mass, m1, right? And this ball also has a mass, m2, right? And this has a velocity v1 or u1, initial velocity u1. Are you following? Or you call that v1 initial, v1 initial, right? Then this also has the initial velocity v2 initial. This is before collision, right? After they have collided, right, we now have again, they still have their mass, m1, but now we have the final velocity, you know, v1 final, and for the second one, m2, we have v2 final. Are you following? Now, because of the principle of conservation of linear momentum, we talked about that in the last class, the principle of conservation of linear momentum, which says that the total momentum before collision is equal to the total momentum after collision. Using that principle, we can say that if we add this together, this and this plus this, and this plus this, they will be equal, right? That's why you have this expression. M1 V1I, that's initial, M2 V2 initial is the same thing as M1 V1 final and M2 V2 final. This equation is for elastic collision, and it is very important. We get this equation from the principle of conservation of linear momentum. Please don't forget that principle. It is very important. So let us take an example to apply this expression. Now, I want to take an example now. Now, a 3 kg ball moving at 9 meters per second. So I want to call that ball my mass 1, the mass of that ball. So my M1 is equal to what now? 3 kg. My M1 is equal to 3 kg. Are you following? Now, my V initial, the velocity of the first ball, the initial velocity of the first ball is equal to what? It's 9 meters per second, 19 please. 19 meters per second. Can you see that now? Now, collides head on with a 2 kg ball. So the second ball has a mass of 2 kg. I want to call that M2 is equals to 2 kg. And that ball is moving with a speed of 21 meters per second. So the second ball is moving, that's V2 initial. V2 initial, right, is 21 meters per second. Are you following? These are the values before they collide, right? Before they collide. Now, after the collision, what happened? After the collision, the second ball, this is mass 2. So it means that my V2 final will be what? Will be 12 meters per second, because after the collision, that is after the collision, V2 final is equals to what? 12 meters per second. 12 meters per second. And what is the final velocity of the first ball? It means we are looking for V1 final, right? I'm looking for V1 final. V1 final. We don't know this. So I want to put a question mark, right? Good. This is what we are looking for. Remember that this type of collision, because after the collision, the two of them move their separate ways, this type of collision is called elastic collision. So we are going to take the equation for elastic collision, which says that M1 V1, that is for initial, plus M2 V2, that is for initial, is equals to M1 V1 for final plus M2 V2 for final. This is the equation. V2 final. Good. If I come to my values, you will see that I have every other thing apart from V1 final. That is this one. I don't have this. So now, let me calculate this. My M1 is 3. I have 3 multiply. My V1 initial is 19. So I have 3 multiply 19 plus. My M2 is what? Is 2. Right? Multiply V2. V2 initial is 21. Right? It's 21. This is equal to my M1 again is still 3 because the mass is not changing. But my V1, I don't know. The final velocity after collision, I don't know for the first ball. So I write this as my V1 final, right? V1 final. So now, after this, plus. But for the second ball, I know the mass and the final velocity, which is what? Which is 12. Final velocity is 12. So my task is easier now. So what is 3 multiply 19? 3 multiply 19, right, is what? 57 plus, we have 57 plus 23, that's 80. So I have 80 is equals to what? So let me write that with another marker. Okay, I want to take this. So I have 80. After I solve this, I got 80 is equal to, this is 3V, right? Because I don't know that V, plus 24, plus 24. No, 21 times 2 is not 24, please. It's 42. It's 42 plus 42. Can you see this now? So I will take this 42 to the other side. Let me remove these ones. I'm sure you know this already. So we are looking for V2. So I will take this 42. So I have 80 minus 42 is equal to 3V. Are you following now? Now 80 minus 42 is 38. 38. 3 and 8 is equal to 3V. So my V will be 38 divided by 3. I'm sure you know this. 38 divided by 3. So if I divide that by 3, I get 12.6. So it means that the final velocity for the second ball is equal to 12.6. 12.6 meter per second. Do you understand this now? So this is how you solve for elastic collision. This is how you solve for elastic collision. Now, let me say that sometimes you will need to introduce minus when the directions are not the same. You can see that in this example, they say they are moving in the same direction. That's why we add them together. But when they are moving in opposite direction, you will subtract because the sign will show the direction of movement. Now, let's go to the second type of collision, which is what? The second type of collision is called inelastic collision. Inelastic collision. Now, for inelastic collision, the total kinetic energy before collision is not the same as the total kinetic energy after the collision. Now, what do we mean by inelastic? Where you have two things colliding, but after the collision, they stick together and move with the same velocity. Do you understand? In elastic collision, when we talk about elastic collision, we say that after the collision, they separate. But in inelastic, after the collision, they move together, right, with the same velocity. That is why, if you look at the equation, you will see that after the collision, we have only one velocity finally. Because after the collision, they are moving with the same velocity, right? The mass will stick together, then they will now move with the same velocity. So this is the equation. So let us take an example for this also, for inelastic. Beautiful. Two bodies of masses 5 kg and 3 kg moving in the same direction along the same straight line with velocity of 5 meters per second and 3 meters per second respectively, suffering inelastic collision. Find the final velocity after collision. So inelastic means that after the collision, they will move with one velocity. So let us solve this problem. Let's solve this problem. Now, two bodies of masses. So the mass of the first body, M1, is 5. The mass of the second body, M2, is 3 kg. The velocity of the first body, V1 is equals to what? 5 meters per second. And that of the second body, V2, is equals to 3 meters per second. Are you following? Now, I'm looking for the final velocity after collision, Vf. I don't know this. This is an inelastic collision. Now, the equation is M1 V1 initial plus M2 V2 initial is equals to M1 plus M2 then multiply by V final. In this example, we are looking for the final velocity. So let's calculate this first. So what is M1 multiply V1? That's 5 times 5. M1 is 5, V1 is also 5, right? Plus M2 is 3, V2 is also 3. Are you following? 3 multiply 3 is equal to M1 plus M2 is 5 plus 3. This is very easy and interesting. Then I don't know my final velocity. So 5 multiply 5 is 25. Then 3 multiply 3 is 9. Then 5 plus 3 is 8 VF. So 25 plus 9 is what? 25 plus 9 is 30 what? Is 34. So I have 34, right? Is equals to 8 VF. I'm sure you can find VF from here. So the final velocity, right, will be equals to, this implies, is equals to what? 34 divided by 8. 34 divided by 8. So what is 34 divided by 8? 4.25. So the two of them will move with the same velocity of 4.25 meter per second. Meter per second. This is inelastic collision. You can see that in the equation, what we have is only one velocity after the collision. We have only one velocity after the collision. Okay. We can now go to the next lesson, which is impulse. Impulse. Now, impulse is telling us the relationship between force and the amount of time you spend in applying that force. So for example, if you are pushing a table, right? So impulse is talking about the force you apply multiplied by the amount of time you use to apply that force, right? That is impulse. Now, so impulse is the product of force multiplied by time taken. Impulse is F multiplied T. Remember that when we talk about momentum in the last class, we said that momentum is equals to mass multiplied by velocity. This is talking about mass and velocity. Impulse is talking about force and time. But there is a relationship between the two of them, right? From Newton's second law, you know that your force is ma, mass multiplied by acceleration. And from grade 9, you know that A is velocity multiplied time. It means that my F is mass multiplied V divided T, as you can see here. Now, when I have that, my F is now equals to mass, multiply V divided by T. I can multiply the two sides by T, this by T times T, and I can multiply this also by time T. Are you following? In this one, T and T will cancel. It means that my force multiply time will be equals to mass multiply velocity. What do you observe here? You will see that this is the formula for impulse, and this is the formula for momentum. It means that impulse and momentum are equal. Impulse and momentum are equal. Now, I have said that impulse is the product of force by the time you use to apply that force, right? That is impulse. It's a very simple concept and very interesting also. So let us take an example to know more about impulse. A mass is sitting on a frictionless surface. An unknown constant force pushes the mass for 2 seconds. From that, you can see that the time is 2 seconds. There is a small mistake in this question. Let me correct it now. The time t is 2 seconds. Not unknown constant force. It's supposed to be a force of. This is wrong. Now, a force of 16 Newton. A force of 16 Newton, not unknown constant force, please. That's a mistake. I'm sorry about that. So 16 Newton pushes the mass for 2 seconds. What was the impulse acting on the mass? Now, the force is equal to 16. The force is 16 Newton, right? This is supposed to be second, not 5. This is 2 seconds, right? 2 seconds. And this is 16 Newton. What is the impulse? Now, we have said that impulse P is equal to force multiplied by time, right? Multiplied by time. Now, the force in this question is 16. Then the time is 2. So 16 multiplied 2 is what? 16 multiplied 2 is 32. Is 32. Now, what is the unit of impulse? It is Newton second. Impulse is Newton second. As you can see, very easy. So this is not an unknown force. It's a force of 16 Newton. So we have the time to be 2 seconds. The force is 16 Newton. And impulse is multiplying the force by the time. And we have 32 Newton second. I hope you understand this. And I hope you find it easy to understand also. Now, if you have any question, please let me know. Then I'm going to, answer your questions. So I wish you good luck. Let's see if we have more. So now we have learned about elastic collision. We have learned about inelastic collision. Then we also learn about impulse and the relationship between impulse and momentum. And I'm sure you understand all that. So please let me know if you have more questions so that I can answer them. And I wish you good luck.